But yeah, this guy says, I'm Mike Danko. I'm Director of Security here at ScriptDrop, which also encompasses infrastructure. Prior to coming here, I was a developer and an infrastructure architect at a company called MariaDB. So I've got a little bit of experience in deploying software, as well as some specific experience in deploying Elixir and Phoenix stacks. Target audience here, really, for what I'm going to talk about is you've dabbled with a little bit, you've got something on your laptop, and you're looking for somewhere to put it, all the way till you've done that, and you need to scale it up a little bit. And I just want to kind of prove that it's not a difficult thing to do. I was going to have this thing where you could follow along, but it didn't work. So deployments. What's a deployment? How do you do it? Well, you just contact these people who run a great company that handle it, and I'm done. Thanks for attending. I'm kidding, but we'll talk a little bit about more of that here in a second. I had to throw in some sort of obligatory meme. There should really be a fifth option that encompasses companies like Netflix, who engineers entire clouds inside public clouds, but I swore this was a newbie talk, so we're not going to go there. And these are just some of the products and companies that you can use if you are writing Elixir apps, Phoenix apps. You can use Heroku, GigElixir, which does Elixir-specific hosting. There's this thing called Kubernetes that you may have heard of, may not have heard of. And then there's the last option that's custom crafting CloudFormation templates for Amazon with Bash, domain-specific language of your own design. If you do that, I'm going to find you. So the title of it was Deployments and Artifacts. What's an artifact? An artifact is the tangible product of software development. That's it. So in Elixir land, more often than not, that means a release. And a release is, well, we're going to talk about that. It is how we package our software for delivery. And our software runs on this thing called the Beam in most cases. And something that a release will do is when you're just developing your software, you run in interactive mode. And that means that your code is loading as you're calling it. When you cut a release, we're going to run your software in embedded mode. And that means that all your code is going to be preloaded, so you don't have to, somebody makes a request to your server, you're not waiting for code to load, everything's going to be snappy. So we've got another thing that releases allow you to do is provide configuration. What does that mean? It means that we can specify arguments to go to that virtual machine, the Beam. So hey, this is how you should run, these are some parameters. There's also environment variables. So an example of an environment variable would be a piece of configuration like an API key for a service that you call. You don't want to put that in your code. That's bad because you need to be able to configure that, change it, and it needs to be a secret. So you stick it in the environment, which is just a way of feeding information to your application. So what else can we do with that? What does a release give us? They're self-contained and optimized. When you build a release, it strips all of your source code. It compiles and it strips all of the stuff out that you don't need to ship to a server to host it. And it's optimized as well by removing all that stuff. One of my favorite things with releases, this tangible object that you get, is that you can have multiple releases. And you may have heard about this thing called an umbrella app, where you have one sort of umbrella application and many child ones under it that kind of live inside it. When you have releases, you can specify, you can specify which one of those applications are started, and you can control, say, I want this key value store to run on this one server, or I want this TCP listener to run on another one. We can configure multiple releases, control how and what child applications are starting, depending on how you actually call that command. So, great, now you know what a release is. What do you get? Nothing, because you just have a piece of software on your laptop that you can look at. So now that you have that, what are you going to do with it? You've got some concerns like, how do I build a release? Where do I build a release? Where do I put my artifact? How do I look at it to know if it's working? How do I troubleshoot it? How do I measure like activity? Like how do I know that I'm getting users? How do I upgrade it when I want new code? And how do I even know that it's on? So let's answer the first question. We're going to do that with containerization, which is in this case, if we're not on Elixir, which they manage, or Heroku, one of these managed providers, they are going to manage all this for you. This is the DIY approach. If you look at the Phoenix distillery, which is the previous way of, well, it's still a valid way of cutting a release, one of the things they'll mention a lot is this thing called Docker, which is just like a lightweight virtual machine to ship your code in, and it's consistent. So this gives us like the target release on our target architecture. So like if you're building this on your Mac, that thing is not going to work on your Linux box that you're serving to. So the Docker encapsulates all that machine stuff and lets you ship the entire machine. That only solves, like I said, it only solves part of the problem. And as the other half of that, we have this thing called Kubernetes, which is well, we're going to explain a little bit more about that. To give you a kind of a brief history of it, if you've heard of it, you probably know what it is. You may not know what it is. It's a way of taking all these Docker containers and sort of scheduling them. It started in 2006, and when Google was working on an internal platform called Bork, it's a scheduler. It's just how they run their software in their organization. It puts things on servers, and it runs this, stops it, starts it, whatever. There wasn't a really great way at that time of isolating processes, meaning that, like, for example, this is a bad example because it's not how it works, but it's a way to think about it, is that they'd have two apps running on the same server, and one would be able to eat all of the available resources and leave the other one in the dust, which is not good. So they contributed some patches to the Linux kernel, which allowed things to be more fair. And this thing was called control groups, or C groups. And then this weird thing happens. We're still in 2007, 2008 at this point, is that people start to hear about this stuff. And this guy by the name of Solomon Hykes starts this company called Docker, which uses some of that technology that came from Google. Some people said that his technology was crap, so they created this thing called Rocket, which was a competing standard. And then everything converged because they realized they were all working towards the same thing. So now we have the OCI, which all the tools are based on. You may use Docker, you may use some other sort of containerization option, but what's under the hood is an OCI compliant container. And on the left-hand side, you had what people were talking about, like how the ideas from Borg spread into other products, how you should sort of schedule things on machines. And this is all happening when cloud computing is just starting to be a little bit more ubiquitous. But again, these are not problems that are solving the problems you have. In the last 4 or 5 years, you see this is a divergent graph. You've got different products coming out that are all sort of related to Borg and do similar things. But it's now convergent because of the same reasons that happened over here. Everyone's working on the same thing. Everyone's coming up with the same best practices. And we get two things out of this. One of this is words codified into language, which we'll get into in a little bit, as well as this piece of software, Kubernetes now, that's 14 years old. So it's there. It's going to be here. It's very mature at this point in a lot of ways. So more about the convergence of the graph. All of the companies that were sort of working on these divergent products ended up saying, we're just writing Kubernetes over again. We're writing our own different version of it. Actually, Alexo and I over there, we're working on a project at another company, and we just found that we were writing Kubernetes at one point. So just use it. So it's a big thing. It's a really big thing. This is the graph. If you go to l.cncf.io, you can view it for yourself. These are the 518 members of the Cloud Native Computing Association or Foundation. These are people that all contribute to these projects They have a market cap of almost $15 trillion, and they've funded all of this to the tune of about 60 billion. Why am I telling you this? Because you came to hear about deployments. Is that you don't probably have that value at your company. You're probably not worth $15 trillion. You have your own ideas, your own things that you need to do. Spending time on writing your own deployment software is not what you should be focused on. If you are worth that much, I'd really like to talk to you. I enjoy my job here, but that's a lot of money. So I talked about this. Okay, solve my problems, Danko. Here are the problems that we had. We figured out the how and where do I build it? Where do I put this thing? How do I look at it? Everything else. The whole Kubernetes ecosystem, and you could just go to Google and they'll give you free credits to run Kubernetes, and like it's free. They call it Google Kubernetes Engine. Amazon does something similar. It all comes in their free tier. So they just have different names for things. So the how we run things, that's going to be in your continuous integration process or Docker. You just build a Docker image. It's like one command. And it's in the Phoenix documentation, which I'll link at the end of this. Where do you put it? You put it in this thing called a container registry. It's just a place where you put the container. It's a fancy name for it. How do you get the information back out again? Well, you have this process called FluentD that you don't worry about it. It just comes with it. You don't even have to install it. And it ships your logs off someplace where you can view them. How do you measure things? With another CNCF project called Prometheus, which is all about gathering metrics. How do you install your software? How do you get it there? That's really easy. Or you could use a more advanced tool called Helm, another CNCF project. It just comes with all this stuff. And how do you know it's working? There's health checks baked into this thing. Like you can't deploy your software in a state where it's broken and your site goes down. So if you have a good release and everything's working and you go to create a new release and go push it and it fails health checks, it's not going to deploy it. So you're safe. The first thing everyone says to me is like, gee, that sounds hard. And you know what, it is. But you know what's more complicated is trying to do it all yourself, because a lot of us have actually been doing that for a while. So the one thing I hear is from people saying, I'm already on the cloud. We have AWS, and like AWS is not a managed platform, because the problems that you need to solve are logging, their metrics, they're maintaining releases, it's uptime, it's load balancers, things like that. And if you're just on AWS, like you're doing all that yourself. So I hope we know that there's benefits to using Elixir in Phoenix and running on the Beam. And I've talked about some of the benefits of running on Kubernetes. What about a combination of the two? Okay, here we go. This is what you were waiting for, Crosby. Stay for the veal. So Kubernetes is a full RESTful API. So you run your software in this container on these servers, and you can query it. You can be like, hey, like tell me the other running instances of this thing. Tell me what other services are on here. Tell me what I can interact with. And it's one of the best APIs I've ever had the pleasure of dealing with. It is, he nods. It's great. And you can, from your Elixir processes, if you're given permissions, you can actually query that and tell me, hey, what are my other nodes? Things like that. There's also a lot of conventions that you get with running on that platform. So like how things are named and addressed. So like you can rely on those as a developer, like DNS and that sort of thing. So how do you do this? It's a lot easier than it sounds. The first thing I'd like to say is be on 1.9. That's dated as of 2 hours ago. You should probably be on 1.10, release candidate 0. There are a lot of enhancements that come to releases. As of 1.9, or 1.9 is the first time releases existed. 1.10, there's a lot of enhancements. Releases were possible with a third-party tool called Distillery prior to 1.9, but there are so many good things that come with 1.9, like runtime configuration. Everything was compile time configuration prior to that, really. that you should just be at least at Elixir 1.9. And then you just run this command called mix release init. It creates 3 files. And the first one, vm.args.eex, is any changes that you need to make to the default beam. And the last 2, you'll only use probably the first one. The last one's if you're on Windows. It's just that's a shell script that will run before you run every command, and we'll see why you do that in a minute. So we're going to edit that file, and we need to set the release distribution to name, which will just tell Beam, hey, talk to these other nodes using their long names. And then the second line there is the release node. That's defining the name. So look things up by name. This is what you find them as names. We're using a host name here, but you can also do things like use DNS or whatever the heck else you want. Kubernetes gives us DNS, probably should use it. This is just an example. So then you need to configure your Elixir app. I'm totally leaving this out. You don't need to. You could be good to go from here. If you don't need to do peering, if you're running strictly stateless, there's no need for your Elixir VMs to talk to one another, you don't need any of these libraries. And these are just 3 libraries that will assist you with to different levels of having communications amongst your different Erlang nodes. So like I said, if you're just running a simple web server, like you don't need this. But it's nice to have, and we'll see what that gives us if you do set it up. The next step is include a Dockerfile. Again, I'm not including it. It's in the documentation. It's very simple. We could look at it. You'd be bored, and you'd have to squint a lot because there's a lot of lines in it. But it's mostly just running your release tasks, which is, again, pretty boring. Okay, so that prepares your Elixir app. The next thing you have to do is create these Kubernetes manifests. So the first thing we have is a service. The software you put in Kubernetes are mortal. They're born and they die, and they're not resurrected. Sounds very sad. If you use a deployment to run your app, it will create and destroy these things on the fly. And these things are called pods. And each pod gets its own IP address, and it just runs on its own, and it's very happy. However, in this deployment situation, a set of pods running at one moment in time could be different than the set of pods running that application later. This leads to a problem. It means that the backends don't know how to talk to the front ends, vice versa. So you have this very simple thing called a service. It just simply is how you know what your app is called, defines what ports it's running on, and just defines the front end to back end mapping. It is a very simple file. This is one that works. In this case, we'd probably have the EPMD port open and port 4000 open on an Elixir deployment. In this case, we just have port 80 running. The other thing that you create, the one of 3, is a deployment. And it is the desired state of your application. And we'll look at one of those files too. It's really simple. It's just a bit of code that it takes the desired state and it beats the Kubernetes cluster into submission until it looks that way. And you can define things in your deployment file, like how many running instances do you have? 1, 2, 3. Do you do rolling updates? And all you have to do for that is say, yes. Defines where you're pulling the software from, and it's where you put in environment variables like your API keys, as well as define what your health checks are. Here's a really simple deployment. It says, run Nginx. Every example is for Nginx or MariaDB. Run 3 replicas, and use the Nginx container, use the image Nginx 1.79, and map that to container port 80. In any other case, it might be, hey, this image is my Elixir app, runs on port 4000. Optionally speaking, you have an Ingress. An Ingress is just a way of defining, like, hey, this is what I'm going to be listening on, so the people from the outside world can connect to my app. It's a load balancer. and it maps your outside requests to the different services inside. And here's an example one, which is kind of cool, is that you get this for free, is that we're going to say we have 2 services running. These could be 2 releases. One could be a PHP app, one could be an Elixir app, where all the requests that go to /foo go to service 1, all the requests that go to /bar go to service 2. And or that could just be / and you could just have the one target. And that would set up your how the world gets to your site. So in summary, you should probably just pay someone to do all that stuff for you. And I mean that in the nicest way possible. Sure. You're paying for this expertise. When you look at the cost of hosting and you look at managed services like Elixir or Heroku, they are darned expensive. They are sometimes 3 to 4 times more expensive than running on AWS yourself. But from that, you're getting an entire team of DevOps people to figure this stuff out for you. Now, if for whatever reason you can't do that, you should pay someone for a platform. So in that case, pay Google Kubernetes, pay for Google Kubernetes Engine. Pay Amazon for a managed service. Don't go straight to EC2. Have this thing that takes care of your release cycles, downtime, landing pages, maintenance pages, all these things that are really important for your product. And to sum up the Kubernetes experience, you just init a release, put a config in releases.exs. That is where you put the runtime configuration, drop a Dockerfile in, add 3 to 4 files for your Kubernetes, and tie it together with something like GitHub Actions. That's like extra credit. GitHub Actions is a set of CI tools and automation tools that work in GitHub that you can actually automate most of this with. And if any of those tools aren't enough for you, and that actually happens. Like, we're in healthcare here at ScriptDrop, and we have a lot of things we have to abide by for compliance and whatnot. So going to some of these managed services aren't something that we can easily do. Kubernetes is an option of something we could do here because it's self-hosted. But if neither of those things or any of those things aren't enough, you must have an incredible market cap, and you should be standing here instead. In case anybody wants to talk later, I try to keep this rather simple, but if you have any more in-depth questions to ask, I could tell you a whole lot about the Go stuff that this is written in. And there's some links. If you go to GitHub, just.github.com/skord, SKORD, it's the gist that's there. And what that is, anyway, since I can't switch that over, that just has several exercises that you can do at home. So if you want to try to take a simple Elixir app and make it run with Kubernetes, great. It has some ones about how to get started with Elixir, or not with Gig Elixir, as well as some advanced ones where there's an example where a fellow from Seattle Elixir deploys a tank application and starts killing the servers off one by one, but everyone in the audience is playing this game and shooting each other and having a good time with zero downtime. So that's a lot of fun. So that's it for me. If anybody needs me later, I'll be here. Yeah. Shoot.
So this might be a dumb question, but how does like Jenkins and TeamCity and like the build automation software tie into Kubernetes?
Okay, so in a number of ways, so if you were to look at something like, there's actually a product called Jenkins Axe that runs specifically as part of your Kubernetes install, and it runs in there. And it runs all of your continuous integration testing, runs all your builds. gives you subdomains for pull requests, like spins up your app, and all this crazy stuff. I would say that if you're starting simply, you'd have your CI run your tests, build your Docker image, push it, and then do the deployment. But yeah, the tooling out there to kind of automate that and put it all in the same cluster of machines is, which Max will probably agree to, it's pretty nuts. Like it takes a full-time team to manage that. But there's a lot of help available, especially in the Kubernetes Slack, if you're ever curious about that. But I'll give you the warning, there's I think 65,000 people in the Kubernetes Slack. It scrolls fast. Okay, there we go. Okay, that was the last thing. I'm not sure where this monitor is in position to mine, so scrolling's hard. There's links to the clustering libraries that I talked about. Some of them are more simple than others. There's a 3-part series about like starting an Elixir app from scratch and then deploying it yourself into Kubernetes. Like I said, you could do that for free on Google. There's a link to the Phoenix docs on the subject because they tell you right off the bat, like, you shouldn't do this yourself. You should build a Docker container and do it this way. And then there's Elixir Seattle's Tank app, which requires pretty sufficient advanced knowledge of Elixir, but is worth a read.